Hi, I'm Ajit, and today we are presenting. I'm presenting on random access memory, which is called as RAM. So as we all know that storage is a very basic instinct of human being. So we want to store whether it is a grain or its past knowledge or memories or knowledge into some so that store that knowledge so that we can use it in our future. So and also we use that in our algorithms and in logic, because in logic we process some data and store that process data somewhere so that we can again that use in the future. So without a memory we cannot have a good logic. And logic memory is a very fundamental thing in algorithms. So there are different types of memory, digital and analog. We mostly store our experience and our memories in terms of analog signals in our mind. But in computers, we have to use digital signals because digital data systems is very simple to control and process. So we use them in our computing devices. So in digital we can also in digital also we can use binary or some other kind of decimals, other kind of storage systems like decimal storage systems or another data systems. But binary is used because at present we have just technical capability in which we can process and store data in just binary form. So we use binary data system. Once our data system is binary, we need to design and fabricate devices which can store our binary data system. As we all know that disk in different magnetic disk, we use the magnetic spin of grains to store high or low value. We can use flip flops in which we can store data, high and low voltage signals, and different parameters can be used to store that binary data. Now depend on these four parameters we can choose for what purpose which kind of storage device we should use. These 4 points: power consumption, access time, storage capacity and reusability. We use different kind of memory such as RAM, ROM, and permanent different secondary memories to store that different kind of data. If we want to store processing data, will use RAM. Use some permanent data that we will never want to edit, that will use ROM. And if we want to store very big amount of data that can be reused, so we will use we'll use external data devices in which we use magnetic disk or some CD disk, that kind of thing. So in this PPT, I'll just explain RAM, how a basic unit of RAM works, so that we can using a huge amount of that basic units we want to we can use uh, we can use it as a processing memory. So as we have discussed in our class, we know how we can store access the data stored in a ROM. So we use address lines and address lines and decoder to access the position data whatever you want. So similarly, in RAM also we can use access, read or write data in RAM using address lines and decoder. But the only this basic storage unit is different in different in RAM. So we'll discuss what are the parameters that we use in basic memory unit. Basic memory unit must take data in and data out. Because it's RAM, we must write and read and write both the data. It may use clock to synchronize with our computer. It may use power. The main four parameters that are required to choose our there are parameters to choose our RAM. These are what volume efficiency. We always want to store maximum amount of data in a minimum space. We want to access data very fast so that we our processes can be very fast so that we can compute very fastly. Power consumption should be very less. So, I'll just discuss three different kind of basic units. First is D flip flop. In D flip flop, we give data at D, and whenever clock is high, the data is transferred to this queue, and data is transferred to queue, which we can use in future anytime. If clock is low on low, whatever value of D is there, Q will retain its initial value before clock going low. So we can read in D and we can read from Q in D flip flop. So another kind of RAM is as RAM, which is synchronous RAM. In synchronous RAM, we use this two CMOS NOT gate and two transistors, using which we can store data in this. So let me simplify this circuit. This two NOT gate can be written in this form. So if uh, this is access line or address line, we call it. This is data lines. So if this access line is low, so that this main memory unit will be disconnected from this to data lines. So if q is 0, then this q bar should be 1 because this is not get, and if q bar is 1, then this should be 0. So this will keep until the power is given to this circuit, and this data will be stored. Now if you want to read that data, this access line will go high, so that this both transistor will be connected to this both line, and data at this this point will be transferred to each line. So using that we can access this data, and if you want to write the data again, we will pass data from these two lines, and that will be stored in this. And this is another basic unit for RAM, which is dynamic random access memory, in which our basic storage data storage component is this capacitor. If this capacitor is fully charged, that is considered as plus, as high, and if it is discharged, it is considered as low. If data is accessed using this word line, this MOSFET or transistor will transfer data from this capacitor to this line. If sorry through this line, and capacitor, if capacitor was discharged, this capacitor will discharge through this capacitor, and so we will get high signal. And if this capacitor will was discharged, this capacitor will discharge through this line, so then we will get low signal, because this this capacitor is charged at lower voltage value, so we will get whatever signal we want. So the basic difference between these two lines is that this timing of this dynamic random access memory is less, time response is less, because it includes capacitors with which may not be as fast as which are not as fast as transistors. So synchronous random access memory is much faster than dynamic, but the main advantage of dynamic random access memory is that its storage capacity is high, because it just use one transistor and two capacitors in each basic unit, so it takes less amount of time. So that is the difference between synchronous and dynamic memory. Thank you.